So hello dear students, today we will solve few numericals on Bragg's law of diffraction. So first numerical is an X-ray of wavelength 1.64 angstrom is incident on a single cubic crystal of lattice constant four angstrom. Find the angle for first and second order diffraction. So solution. So as wavelength is 1.64 angstrom, so it is 1.64 into 10 raised to power minus 10 meter. Lattice constant small d is 4 angstrom, so it is 4 into 10 raised to power minus 10 meter. So according to Bragg's law, two d sine theta, it is equal to n lambda. So for first order diffraction, as we know small n is equal to 1, so it will be 2d sine theta 1. Theta 1 is angle of diffraction for first order diffraction, lambda upon 2d. So lambda is equal to 1.64 10 raised to power minus 10, 4 into 10 raised to power minus 10. So when we solve this, it will be 0.2050. So sine theta 1 is 0.2050. So from log table we can find the angle, and it is 11.83 degree. Now as we are to also find the angle of diffraction for second order diffraction, so for second order diffraction, n is equal to 2, so we will be having 2d sine theta 2, it is equal to 2d 2 lambda. So sine theta 2, it will be equal to lambda upon d, 1.64 10 raised to power minus 10, 4 into 10 raised to power minus 10, so it will be 0.41. So sine theta 2, it is equal to 0.41. So theta 2 angle, it will be 24.2 degree. We can get this angle from the log table. So this is a very important question related to Bragg's law of diffraction. Simple one, very important for exams. The second numerical is determine the glancing angle on a Q face of a rock salt crystal corresponding to second order diffraction. Given small a is equal to and lambda is equal to so dear students, as in the Bragg's law we have 2d sine theta to n, it is equal to n lambda. So here we are to deal with second order diffraction. N is equal to 2, so 2d sine theta 2, it is equal to 2 lambda, 2 cancels out, so sine theta 2, it is equal to lambda by d. So this is similar to previous question. So one difference is there. In the previous question we are given d directly, but in the present question d is not given to us, rather we are given edge length and we are given the Miller indices. So from here Miller indices are h is equal to 1, k is equal to 0, l is equal to 0. So small d, it will be equal to a upon h square, k square, l square. So small a is equal to 2.814 angstrom, h is 1, k is 0, this is 0. So d comes out to be same as small a. So from 1 and 2 we can get angle for second order diffraction. So lambda is 0.710 angstrom and d is 2.814 10 raised to power minus 10. So if we solve this, it is 252. So now we need a log table or a scientific calculator to find the angle, and using that you can very easily get the angle for second order diffraction equal to 14.6 degree. So now we come to numerical number 3, the Bragg's angle for first order reflection. So you can say reflection or diffraction, it is the same thing. When you study the derivation of Bragg's law, you can get this from a plane 1 1 1 in a crystal is 60 degree. Calculate the interatomic spacing. If the X-ray of wavelength 1.8 10 raised to power minus 10 meter is used. So this numerical is different from the previous ones because in the previous questions we are to calculate angle of diffraction, but here angle of diffraction is given for first order. So theta 1 is given to be 60 degree and our plane is 1 1 1. So h is equal to 1, k is equal to 1, l is equal to 1. Wavelength is 1.8 10 raised to power minus 10 meter, and we are to calculate interatomic spacing. So what is the symbol for interatomic spacing? Here interatomic spacing is represented with A. But Bragg's law is 2d sine theta, it is equal to n lambda. So firstly we have to calculate d, then we are to write the relation between d and a, and finally we will get a. So this will be our roadmap for first order diffraction. Small n, it is equal to 1. So 2d sine theta 1, it is equal to 1 into lambda. So sine theta 1, it is equal to lambda upon 2d. No. Firstly we have to calculate d. So we have to write this way. D is equal to lambda upon 2 sine theta 1. So lambda is 1.8 10 raised to power minus 10 to sine 60 degree. So it is 1.8 10 raised to power minus 10, 2 into sine 60 is root 3 by 2. So it comes out to be 1.8 10 raised to power minus 10 divided by root 3 meter. So here we obtained d. Now we will write the relation between d and a. As we know, d is equal to a divided by h square, k square, L square, and value of hk and L are 1, 1, 1. So when we substitute this, so it will be d a divided by 1 square, 1 square, 1 square. So d is equal to a divided by root 3. So a comes out to be root 3d. So root 3, 1.8 10 raised to power minus 10 divided by root 3. So a is equal to 1.8 10 raised to power minus 10 meter. So dear students, this is the solution for interatomic spacing. So you can solve more numericals from the book as well. This completes today's part. Thanks a lot. Keep in touch for next lectures. Thanks again.